New discovery on Mars and rovers. The InSight Mars rover, also known as the Interior Exploration Using Seismic Investigations, Geodesy and Heat Transport InSight, is a robotic lander mission designed to study the deep interior of the planet Mars. The mission was launched on May 5, 2018, and landed on Mars on November 26, 2018. The InSight lander carries several scientific instruments, including a seismometer, a heat probe, and a radio science instrument, which are designed to help scientists study the interior of Mars and gain a better understanding of its formation and evolution. The seismometer is used to detect and measure Marsquakes, while the heat probe is used to study the flow of heat from the interior of Mars to its surface. The mission has provided new insights into the structure and composition of Mars, including the discovery of a liquid water lake beneath the surface of Mars. InSight has also detected hundreds of Marsquakes and has helped scientists better understand the planet's tectonic activity. The InSight mission is a collaboration between NASA, the French Space Agency, CNES, and several other international partners. The mission was originally planned to last for 2 years, but its operations have been extended several times, and it is currently expected to continue operating until at least December 2022. Tell me more about the InSight lander. Carries several scientific instruments, including a seismometer, a heat probe, and a radio science instrument, which are designed to help scientists study the interior of Mars and gain a better understanding of its formation and evolution. The seismometer is used to detect and measure Marsquakes, while the heat probe is used to study the flow of heat from the interior of Mars to its surface. Sure, I'd be happy to provide more information about the scientific instruments on board the InSight lander. The seismometer on board the InSight lander is known as the Seismic Experiment for Interior Structure, SEIS. It is a highly sensitive instrument designed to detect and measure the tiny vibrations or Marsquakes that occur deep within Mars. By studying these vibrations, scientists can learn about the interior structure of Mars, including the thickness and composition of its crust, mantle, and core. In addition to Marsquakes, SEIS can also detect other types of seismic activity, such as meteorite impacts and dust storms. The heat probe, also known as the Heat Flow and Physical Properties Package, HP3, is designed to study the flow of heat from the interior of Mars to its surface. The probe is designed to drill up to 16 feet, 5 meters, into the Martian surface and deploy a temperature sensor to measure the heat flowing out of the planet. This information can help scientists understand the thermal history of Mars and the processes that drive the planet's geology and weather. The radio science instrument on board the InSight lander is known as the Rotation and Interior Structure Experiment, RISE. RISE uses radio signals to precisely measure the rotation and wobble of Mars, which can provide information about the planet's interior structure, such as the size and density of its core. This information can also help scientists study the planet's atmospheric and surface properties. Together, these instruments on board the InSight lander are providing scientists with unprecedented insights into the interior of Mars, and helping to answer long-standing questions about the planet's formation and evolution. Can you tell me anything about a meteor hitting Mars in 2021? I'm not aware of any meteor impacts on Mars in 2021, as my knowledge cutoff is in September 2021. However, I can provide some general information about meteor impacts on Mars. Mars is known to have a much thinner atmosphere than Earth, which means that meteoroids and asteroids can reach the surface of the planet more easily. As a result, Mars has a heavily cratered surface that bears witness to the planet's violent history of impacts. In fact, the largest volcano in the solar system, Olympus Mons, is thought to have formed from a massive impact that caused a huge lava flow. Mars also has the largest impact basin in the solar system, called the Hellas Basin, which is thought to have been caused by a giant impact early in the planet's history. Meteor impacts on Mars can also have important scientific implications. When a meteorite hits the surface of Mars, it can create a blast that sends dust and debris into the atmosphere. This dust can be carried by winds around the planet, providing scientists with important information about the Martian atmosphere and climate. In addition, meteorites that are found on the surface of Mars can provide valuable information about the composition of the planet's crust and mantle, as well as the history of the solar system. What else could you tell me about THR rovers? Sure, I'd be happy to provide some more information about Mars rovers. Mars rovers are robotic vehicles that have been sent to Mars by various space agencies, including NASA, ESA, and CNSA. These rovers are designed to explore the surface of Mars, collect data and samples, and transmit the information back to Earth. The first Mars rover, Sojourner, was launched by NASA in 1996 as part of the Mars Pathfinder mission. Since then, several other rovers have been sent to Mars, including Spirit and Opportunity, Curiosity, and Perseverance. Each Mars rover has been equipped with a variety of scientific instruments designed to study different aspects of Mars, such as the planet's geology, climate, and potential for life. For example, the Curiosity rover is equipped with a laser that can vaporize rocks and study their composition, while the Perseverance rover is equipped with a drill that can collect rock and soil samples for future analysis. One of the challenges of operating a rover on Mars is the distance between the planet and Earth. It takes several minutes for a signal to travel from Earth to Mars, which means that rovers must be designed to operate autonomously for extended periods of time. In addition, the rovers must be able to survive the harsh Martian environment, which includes extreme temperature swings, high levels of radiation, and occasional dust storms. Despite these challenges, Mars rovers have been incredibly successful in expanding our knowledge of the Red Planet. They have discovered evidence of past water and geological activity, identified potential sites for future exploration, and helped scientists understand the potential for life on Mars. Sure, here are some additional details about Mars rovers. One of the key features of Mars rovers is their mobility. Most Mars rovers are equipped with wheels that allow them to traverse the rocky and uneven terrain of the Martian surface. The wheels are designed to be sturdy and flexible, with individual sections that can rotate and flex to help the rover navigate obstacles. Mars rovers are also equipped with a range of scientific instruments that are designed to study the Martian environment. These instruments include cameras, spectrometers, and sensors that can measure temperature, pressure, and radiation levels. The data collected by these instruments is used to study the geology, chemistry, and potential habitability of Mars. To communicate with Earth, Mars rovers use a combination of antennas and orbiters. The antennas on the rovers transmit signals directly to Earth, but the signal strength is limited by the distance between the two planets. To overcome this limitation, Mars rovers also communicate with orbiters that are in Mars orbit. These orbiters act as relays, receiving signals from the rovers and transmitting them back to Earth with a stronger signal. Another important aspect of Mars rovers is their power source. Most Mars rovers use solar panels to generate electricity, but the panels can become covered in dust during dust storms, reducing their efficiency. To mitigate this risk, some rovers are equipped with dust removal systems that use brushes or air jets to clean the solar panels. Overall, Mars rovers are remarkable machines that have expanded our knowledge of the Red Planet and helped pave the way for future exploration. Their successes have inspired new missions and new technologies, and they continue to provide valuable insights into the mysteries of Mars. What other problems have they had with them? Like and subscribe, it helps my channel grow. Welcome. Operating rovers on Mars is a complex and challenging task, and various issues have arisen during the missions. Here are some examples of problems that have affected Mars rovers. Dust storms. Dust storms can pose a significant risk to Mars rovers, as they can reduce the amount of sunlight reaching the solar panels, leading to a drop in power. During the 2018 global dust storm on Mars, the Opportunity rover was unable to generate enough power to operate and ultimately went into hibernation mode, never to be reactivated. Mechanical issues. Mars rovers are complex machines with many moving parts, and mechanical issues can arise. For example, during the Curiosity mission, one of the rover's wheels developed a crack, requiring the mission team to adjust the rover's driving strategy to avoid further damage. Software glitches. Like any computer system, the software that controls Mars rovers can encounter glitches or bugs. In 2004, the Spirit rover experienced a software issue that caused it to reboot unexpectedly, leading to a delay in the mission. Communications problems. Mars rovers rely on communication with Earth to operate, but this can be challenging due to the distance between the planets and the limited bandwidth available. During the Spirit mission, the rover experienced periods of reduced communication with Earth due to a series of events, including a solar flare and a problem with one of the orbiters. Despite these challenges, the missions have been successful overall, and the scientific discoveries made by Mars rovers have been invaluable in expanding our understanding of the Red Planet. Thank you for watching. Hope you enjoyed. New discovery on Mars. In an incredible first, scientists have discovered what's at the core of Mars. Space 25, April 2023. By Michelle Starr. Artist's impression of the internal structure of Mars. IPGP/David Ducrot. Quakes rumbling through Mars have been detected rolling through its gooey core for the first time, giving scientists the tools they need to figure out what, exactly, Mars' heart is made of. According to seismic data obtained using NASA's InSight lander, which monitored the red planet's innards for 4 years, Mars' center is a liquid iron alloy, with surprisingly large amounts of sulfur and oxygen mixed in. It's information that can help scientists better understand Mars' history, and why it is different from Earth, one planet an arid, lifeless dust ball, the other lush and teeming. In 1906, scientists first discovered the Earth's core by observing how seismic waves from earthquakes were affected by traveling through it, says geologist Vedran Lekic of the University of Maryland. More than 100 years later, we're applying our knowledge of seismic waves to Mars. With InSight, we're finally discovering what's at the center of Mars and what makes Mars so similar yet distinct from Earth. Quakes aren't just rumbles that imply internal activity in any given object. We now have the technology to use them as a sort of acoustic X-ray. Remember to like and subscribe. They propagate outward from their point of origin, bouncing around inside a planet or moon or star before stilling to quietness. But the way they travel through, and reflect off, certain materials allows scientists to generate maps of the interior compositions of these bodies. During its relatively short time monitoring the interior of Mars, InSight detected hundreds of Marsquakes, giving us detailed information about the Martian interior. From this, scientists were able to compile the first detailed map of the guts of Mars, and learn more about the state of Mars' interior activity. Spoiler, it's not nearly as dead inside as we thought. The Martian core remained unprobed, but in 2021, InSight logged 2 tremendous events on the opposite side of the planet, a giant Marsquake bigger than anything the lander had detected, and a meteorite impact that rattled Mars. Because these events were on the far side of the planet from InSight, the lander could analyze different waves, those that traveled around Mars, and those that traveled through it, giving us the first seismic waves that we know moved through the Martian core. Artists' impression of the path traveled by seismic waves through the Martian core. NASA/JPL and Nicholas Schmerb. These waves reveal the density and compressibility of the different materials they travel through, allowing a team led by planetary scientist Jessica Irving of Bristol University in the UK to break down what the Martian core is made of. And here's where it's interesting. As opposed to Earth's core, which seems to be a liquid outer core, a solid inner core, and then an even denser innermost inner core, Mars' core seems to be squishy liquid all the way through. And Mars has a really high proportion of lighter elements mixed in through the inner core. Around a fifth of its weight is made up by these elements, predominantly sulfur, with smaller amounts of oxygen, carbon, and hydrogen. This means that the core is less dense and more compressible than Earth's core, which could help scientists better understand the differences between the two planets. We've long known that Mars doesn't have a global magnetic field. On Earth, the magnetic field helps keep the atmosphere and water from leaking into space. Known as the geodynamo, this is produced in Earth's core. Heat moves from the inner core to the outer core, which generates circulating currents that twist into patterns under the influence of the planet's rotation. This creates and maintains the magnetic field. Previous research in which scientists simulated the Martian core suggested that the presence of lighter elements in Mars' core could have played a significant role in killing its dynamo and magnetic field. Now we have detailed information on what's actually in there so that scientists can reconstruct the history of Mars more accurately. It's like a puzzle in some ways, Lekich says. For example, there are small traces of hydrogen in Mars' core. That means that there had to be certain conditions that allowed the hydrogen to be there, and we have to understand those conditions in order to understand how Mars evolved into the planet it is today. This information could help hone our ability to search for life outside the solar system. Mars and Earth are similar in many ways. Working out how they differ, and why, can help scientists narrow down which alien worlds are most likely to host life. And it can teach us more about the different ways planets form, grow, and change over time, even from similar materials around the same star. This was a huge effort, involving state-of-the-art seismological techniques which have been honed on Earth, in conjunction with new results from mineral physicists and the insights from team members who simulate how planetary interiors change over time, Irving says. But the work paid off, and we now know much more about what's happening inside the Martian core. The research has been published in the Proceedings of the National Academy of Science. Like, comment, subscribe. Thank you for watching. Hope you enjoyed.